The final piece of this discussion will focus on two more intermediate operations, dropWhile and takeWhile. And they are both stateful, short-circuiting intermediate operations that were introduced in Java 9. They were not part of the original set of operations that were put forth in streams in Java 8. So let's talk about dropWhile first. So what dropWhile does is if the stream is unordered, it returns a stream of the remaining elements of the stream after dropping a subset of elements that match the given predicate. And we'll take a look at an example here where we're going to do some stuff where we want to drop a bunch of things that are not equal to something. And the semantics are slightly different. If the stream is ordered, and I'll talk about ordered versus unordered in a second, then return a stream containing the remaining elements of the stream after dropping the longest prefix of elements matching the given predicate. So what does it mean for a stream to be unordered? That means we don't care about the order in which stuff is. Ordered is not the same thing as sorted, by the way. It just basically says if there's an ordering where you want to take the first item needs to be considered first, followed by the second item. Something like a list is an example of an ordered collection or an ordered stream. A list converted into a stream is an ordered stream. And I made it look as though it was sorted. It's not really sorted, it's just ordered. Ordering matters. If you have something where order matters, then it will treat it slightly differently. An ordered collection would be something like a set that's going to be in sorted order, although sorting and ordering are two different things. dropWhile is a stateful operation, and that's because it needs to keep track of what has come in order to know what it should do when it gets the next element. And this is important because if you use it on an ordered parallel stream, then it will end up being very expensive to run. So probably not a good idea to use dropWhile on a parallel stream where the input is ordered in some way. Let's take a look at an example here. So this is going to demonstrate the use of dropWhile. Now, notice that at first glance, dropWhile looks a bit like filter in that the number of output stream elements may be less than the number of input stream elements. So at first, it looks like it's very much like filter. However, the semantics of dropWhile are different from the semantics of filter. And in particular, with filter, it's a run to completion operation. So it has to look at every element in the stream, deciding whether or not to let it through or not. With dropWhile, it's a short-circuiting operation. And as soon as the predicate is no longer true, it'll stop. So it'll drop while the predicate. And if it's false, then it'll stop dropping. Another thing is, which is similar to filter, is that it can't change the type or the values of the elements it processes. It just basically will either stop or continue. So let's take a look at an example of applying this. So what we're going to do here is we're going to take a list of results that come out of our SimpleSearchStream program, and we're going to put them into a map, and we're going to sort them in the encounter order. So that'll be do, re, mi, fa, sol, la, ti, do. That's the order that they're going to be in the map, even though it's hashed. So that even though this is kind of confusing at first glance, the elements in the map will be hashed, so you can do essentially constant time, average case lookups and retrievals and so on the map, insertions and removals. But when we iterate through the map, we're going to do it in the order it was encountered. So it'll be do, re, mi, fa, sol, la, ti. And so what we're going to do then is we're going to use this particular mechanism in order to be able to essentially search in this map for one of the keywords like ti or la, which comes later than do, re, mi, and we're going to keep dropping while we haven't found ti or let's see, re, and we're going to keep dropping it. And once we hit the one we're looking for, then at that point we will print everything from there onwards. So what we're doing is we're dropping them while they don't equal the word we're looking for. And so we're going to ignore everything up to the point where we find a match, and then from that point onwards, we're going to print all the results out. So convert the list of search results into a stream, collect them into a map with the words as the keys, convert the map into a stream of entries, and then ignore the entries until there's a match. And the not equal method here is defined as not the key equals the word we're looking for, to make everything fit on one slide. And so we start printing the results starting at the match. So that's dropWhile. Let's take a look at takeWhile. So takeWhile is another operation. It is very much like dropWhile. It's a short-circuiting stateful operation. However, it behaves slightly different. If the stream is unordered, return a stream consisting of the subset of elements taken from the stream that match the given predicate. So what it does is, as long as the predicate is true, it'll include it in the stream that it's outputting. As soon as the predicate is false, no more emissions up from that input stream. And there's also some issues about ordering here, and you have to be careful with parallel streams. So long and the short of it is avoid using parallel streams with ordered collections with takeWhile or dropWhile because they're really slow. As with dropWhile, takeWhile will return a subset, may return a subset of the elements depending on the matching, but it's not like filter because it's short-circuiting. Filter is not short-circuiting. takeWhile is. Also, like dropWhile, you can't change the behavior or the types or the values of the input stream. You can only decide to stop emitting at some point. And here's an example that illustrates how this works. So in this particular case, what we're going to do is we're going to take the list of search results, turn it into a stream, collect it into a map where, once again, we obey in counter order. So it's going to be do, re, mi, fa, sol, la, ti when we want to walk through the stream. And then we convert these elements into a stream. And in this case, what we do is we give it a particular thing we're looking for, and it's going to take while the entry matches that, and as soon as it's going to say you have do, re, mi, fa, sol, la, ti, do, and you say mi. What it'll do is it will essentially keep taking the element until it reaches the one you're looking for. So it'll basically print a prefix slice as opposed to a suffix slice. And so it's going to ignore it after it's not, once it finds the word it's looking for, it's going to ignore everything else. And so it'll print the result starting at the beginning and continue up to, but not including the match. So this is a prefix slice as opposed to sort of a suffix slice. So that's the end of dropWhile and takeWhile, which are very interesting operations.